Okay, this video is for Chapter 9 review. This is part 2, starting at question number 18. Why might constellations vary with different cultures? So, the constellations are an interpretation of patterns. So, they aren't any real set pattern in space, but it's just the way we view them on Earth, and those are going to be influenced by our culture or our beliefs. 18 is the scientific understanding of constellations and asterisms in the sky on star charts misleading. Explain. Yeah, one possible answer is yes, it could be misleading because many cultures have patterns that differ from Eurocentric model. By only using one type of chart, the user is led to falsely believe that this is the correct version. Really, when it comes down to it, all versions are valid. Question 20. First Nations and Métis people used observations of the natural world around them as a way to know the changing of the seasons. How did they use the sky's way to indicate the change of seasons? Many First Nations and Métis people use the appearance of certain constellations as an indication of changing seasons. Some also use the amount and location of sunsets and sunrises to anticipate changes in seasons using medicine wheels. So it's very similar to other cultures. Like if you do remember back from when we did ancient civilizations and social studies, when Sirius or the Dog Star showed up in Egypt, they knew that the Nile River was going to flood soon and it was time to get the crops ready. Question 21. Your friend claims that summer occurs because Earth moves closer to the sun. Is your friend correct? Explain why and make a sketch to illustrate your answer. It's hard to believe how many people believe that, but it is incorrect, that assumption. The seasons occur because of the Earth's tilt, and due to the Earth's tilt staying in the same direction all the time, it's whatever side is tilted towards the sun, that is the one that is going to experience the summer at that time, and the opposite one's going to experience their winter. If neither end is tilted towards the sun, that is a equinox period, either a spring or fall. 22. Earth has several other kinds of motion besides rotation and revolution, like the axis of a spinning top changing the directions in which it points. Earth's axis of rotation slowly changes direction, though the axis will still be tilted at 23.5 degrees. This motion, called precession. Research precession, including how long one complete cycle takes and where Earth's axis points now and where it will point later. Present your findings in the format of your choice. If you did this one, I would be very impressed, but it would definitely not expected. So precession refers to a slow change in an astronomical body. For Earth, this change occurs to the tilt of Earth's axis. The ancient Greek Eratosthenes observed that the location of equinoxes were in different positions than they had been recorded 150 years previously. Okay, 23. What are some of the positive and negative effects that the sun can have on the Earth? Good question. The sun provides energy for life on Earth, and with the Earth being in the place that it is in the solar system, it receives just the right amount of energy for life to exist based on the amount of heat we receive. Our atmosphere and weather is affected by radiation from the sun. As beneficial as the sun's radiation is to Earth, too much can cause problems, especially for humans. They can develop skin cancers from too much exposure to the sun. Solar flares can cause damage to technology, not only on the planet, but to technology that orbits the Earth as well. 24. All cultures respect the importance of sun to life on Earth. With advances in technology, sorry, I lost my spot. Technologies. Humans have learned much more about how the sun affects Earth. Describe the variety of ways the sun affects life on Earth. Um, so various answers could be included for this one as well. Plants and some algae use sunlight and photosynthesis. The conversion of light energy to chemical energy is the basis of all of Earth's food chains. The sun's radiation directly affects the weather patterns, climate, and atmosphere on Earth. The sun and its effects also have been a source of spirituality for many different cultures. 26. Sorry, 25. Many First Nations respect the Aurora Borealis. Explain the reason for doing this. How might this respect be linked to their survival? Okay, First Nations and Métis people use their observations to develop their explanations for the natural world. One explanation might be because the auroras occur in the evening, and in the past they were not the lights that we have today. The evening could be a time of danger. Visibility would be limited, and many animals can hunt at night. So the stories might have been developed about seeing the northern lights and the possibility of danger that might exist. That's possibly one thing. Okay, 26. Briefly name and describe the two theories of formation of the solar system discussed in this chapter. Compare the similarities and differences. Okay, so we discussed this earlier in the other videos. The two theories that we talked about were the nebular and the Allen-Boss theory, where they discussed how the solar system was formed. So in this theories, there is very similar things between the two about the gases and the dust, which came from the sun, later formed the planets, to just sum it up briefly. The big difference is that with Allen-Boss, the gas giants were influenced by a second star in his belief. So that one I find a little more difficult to believe, but remember, they're just theories. Question number 27. How does the distance from the sun directly affect the composition of the planets in our solar system? The closer they are to the sun, the heavier, the more rocky they are. So our four closest planets to the sun, Mercury, Venus, Earth, and Mars, are all rocky planets. Anything beyond Mars is considered a gaseous planet. So Jupiter, Saturn, Uranus, and Neptune are all gaseous planets. So one way of explaining that, according to nebular theory, is as the sun was formed, the gases and dust were spun outward away from the sun, and the lighter gases were flung farther than the dust. The dust, which was heavier than the gases, was more affected by the gravity of the sun, and thus allowing for the creation of rocky planets. As the gases went farther out, they mixed with some dust, creating the outer planets. Question 28. The four gaseous outer planets are by far the largest planets in the solar system. What might be one explanation for how they grew to be much larger than the four inner planets? One possibility, I guess, based on the nebular theory, and that would be that the location was so far away from the sun that a lot of the gases formed ice, and the ice started to act as glue, causing more dust and gases to stick together. This caused the outer planets to grow larger and faster than the inner planets. Question 29. Suppose a gaseous planet half the size of Saturn were discovered. Where in the solar system do you think it would be located? Give a reason for your answer. Okay, so your answers could vary on that one, but a gaseous planet, which is half the size of Saturn, well, it would have to be an outer planet. And it should be farther from the sun than Saturn. The farther a gaseous planet is away from the sun, the smaller it is. So if there was one to exist, I would say it is quite a ways out because we haven't observed it yet. Question 30. When an asteroid strikes Earth, it can cause great damage. A pair of asteroids simultaneously crashed into the Canadian Shield, as shown by the image below. Suggests how it might have happened that two asteroids crashed at the same time. Hope you used your filters on that question when you read it like I did. One possibility for that happening is that when that asteroid hit the Earth's atmosphere, it heated up and it caused it to break into two pieces, and then they both hit the Earth virtually at the same time. Okay, question number 31. The star Aldebaran, is visible from Earth, lies about 65 light years away from us. What is the minimum amount of time that would be required to send a message to Aldebaran and receive a reply, assuming that someone was there to receive the message and respond? So if we sent a message at the fastest speed we possibly could, so we'd send something at light speed. So even if we could get that message to travel at light speed, it would take 65 years to get there and 65 more years to come back. So that would be a total of 130 years. So a lot of those messages sent in are various sci-fi movies we watched in the past. They are very realistic. Okay, reflection number 32. This chapter focused on the solar system and Earth's place in it. We have learned much about our solar system with improved technologies over time. Do you think that people should continue exploring our own solar system, or should they now be focusing their attention beyond our solar system? Explain your thoughts on this. Well, there's definitely two ways of looking at it. I think we should still continue on sending up our telescopes and looking into deep space and keep looking for new stars, new planets, new black holes, so on and so on. But I think our greatest emphasis, personally, for me, is to focus on studying our own solar system. We have so much still to learn about our own solar system. And even though it is vast in size, we can still send probes out into our solar system and get good information back. We might have to launch something and wait 5, 10, 20, 30, 40 years to get that information sent back to us. But we can still do that. But to send it out to a star like Aldebaran, we would never get that there in 10,000 years. So there's no way a probe is going to last that time. So I think we should focus mainly on the solar system, keep sending probes out, keep learning about our own planets, but we can still use our telescopes to examine deep space.